So, very good evening, everyone. Thank you for joining us today for another session on OT security. This time, we are discussing a very specialized topic getting started with automotive security. And if you are new to this platform, my name is Shiv, and I do this OT security specific sessions continuously. So far, we have done close to 16 different sessions, and all our previous recordings are available in YouTube. So if you want to learn more about OT security, like topics, risk assessment, and 62443, you can go and watch our previous episodes. Having said that, let's get into the discussion for the day. Joining me today is Arun. Arun is a very well known expert in automotive security. I'll introduce him in detail in a while. But I'll welcome you, Arun, for taking time today and then joining the session.
Thank you.
Okay, so before getting started, let's wait for few more seconds so that people can join and then we'll continue with the agenda. Okay, so now we have sufficient count. Welcome back again. So let's get started. So I'll welcome you, Arun. Thank you for finding time and then putting up the agenda of the day. So to people who joined online, let me introduce Arun to you. He is a visionary and a trailblazer in security, innovation, and education. He is also founder and CEO of AminaSec and co-founder and CEO of Uno Academy, a distinguished training provider. His work revolves around automotive security, though he has started his career in ICS as well, and I think he was one of the few who started ICS security back in 1516 itself. I get to know him last year with some mutual connections and some of the work that he has put on LinkedIn, and then we tried to connect together and then discuss these topics, and ultimately uh, we concluded this year that we'll do this session. So I'm again thankful to you, Arun. I know
Thank you so
this
much.
discussion was only 3 days, and then you really have to put the hard work to put up the slides and then finalize the agenda and put up the agenda of the day. So, before we begin with the day as agenda, just a friendly reminder about the work that we are doing here is out of our personal interest. This has nothing to do with the organization we are associated with, and the opinions that we express here are the opinion that we have about this particular topic and not the opinions of the organization as such. So today we'll be focusing on the automotive security, and we will discuss what do we mean by automotive security, why should we be worried about the automotive security as such, some challenges which are unique to the automotive cybersecurity areas. Then, since it's the session itself says that how do we get started, then we'll get into uh, some basic guidance. How can you start your journey in automotive security? We'll also see bunch of international standard which are working towards putting the cyber security for automotive area, and finally some key areas to focus when you are doing automotive security, and finally we'll take some question answers. Having said that, just one more friendly reminder, since this is the first session we are doing on automotive security, we'll try to give you a broad understanding of the topic. We might not go deep on one particular area, but we intend to do more focused discussions. This automotive security topic is very vast, and in next slides we'll get to know about them. And I just also want to add one cent from my side that when you talk of automotive security, people do understand that it's a security not about the vehicle but also the manufacturing plant itself. But both the things are different. There is a security that is required for the vehicle, the control system in the vehicle, and there is also security requirement of the manufacturing plant. So our focus today is the vehicle itself, your two wheelers, your four wheelers, which are being controlled by different controllers. We will discuss the security aspect around it. So again, uh, I thank you all for joining the session today, and I hope that you will learn a lot about the automotive security topic. I am also learning this thing a bit today, and looking forward to have a very good, knowledgeable discussion with you, Arun. So now I'll hand it over to you, Arun. Welcome you once more, and let's get started then.
Yeah, I hope I'm audible very well over here.
Yes, yes,
Okay, thank you so much having me over here, Shiv, and Shiv, you and the Manjunath doing very great job over here because spreading knowledge about cybersecurity awareness, knowledge regarding 62443, which is very essential part for the manufacturing units in that case, the entire domain, and it's very necessary and very important in the industrial control systems. So I'm really hats off to you and Manjunath. You are doing great job over here. I'm really happy about that.
thanks, Arun. This is our adrenaline.
That's good. Okay, so let's start. Today we are going to talk about the automotive security, how we can go into in this domain, very different domain from the other industries like banking sector, then IoT. In that case, it's though it's a part of the IoT, it's also part of the automotive industry itself. But again, it's a very different arena altogether, very different architecture, and different kind of terminologies they used in this industry. I understand that when I started ICS first time in 2015, started hardware hacking in 2014. In 15, I moved into the ICS environment, SCADA systems and DCS. So I learned a lot about the terminologies. The same here when I started in 2016-17 research on the automotive industry. Again, I learned different kind of terminology. So here some of people coming from the ICS, definitely I will match that, I'll bridge that gap actually in terms of automotive and the ICs in that case. Okay, why automotive industry? So it's very big, very vast and essential sector worldwide in that case.
Yeah.
So that's very, we need to understand first how the automotive industry encompasses the design, production, and sales. It has a three kind of department in the automotive industry. So first system, and then software, and the hardware. These three departments comes together and come up with a vehicle in the physical world. So it's come from the design and then ideas and a lot of hardwares they require. On the hardware they need to uh, make a software or apply software or download a flash on the hardware itself, the entire applications, the design, and then they come up with the vehicle itself. So in that case, it's a lot of efforts involved in that case. As per German standard, I would say, because a lot of OEMs from Germany nowadays, you can name it, big automotives giants are from Germany.
Yeah.
It takes 4 years to design the entire vehicle, 4 to 5 years, design and workable, and it have lot of procedure in that case. There are some OEMs on entire world they make it in 1.5 year, 2 years, 2.5 years as well because of competition. So there are some OEMs around the world that do that. So you can see over here, it's a big and vast, sector entire worldwide. It's a significant. It gives significant impact on global economy. So there are a lot of things are there in the recession crisis as well. In 2008, 2010, you can if you search from Google or internet, you will come to know what is the significant impact of this automotive industry on the global market. Technological advancement are rapidly reshaping the industries. You can see all over world. You can see nowadays a electric vehicle going on, right? So now industries from mobile industry is now making a vehicle. So you can understand why this mobile industry coming into the suddenly in vehicle industry. So you can search the name of that particular OEM on the internet. So again, it's very competitive market. And even if you see these kind of facilities, whatever see on the mobile itself, you can see in the automotive uh, vehicle in that case. I'm talking about the infotainment system in that case. So to protect this kind of architecture or design in that case, to measure and protocols to implement the protect vehicle systems and networks and data from the cyber threat. That is exactly the automotive security. So let's understand a little bit in depth. So here I can show you the external and internal some sort of communication over here. So if you see the control engine, parental control, in that case, airbag on the left side, uh, from the airbag deployment, adaptive front lightning, adaptive cruise control, automatic braking, electric power steering, electronic throttle control, OBD2, active vibration control. These are the different kind of features for the smart car, I would say in that case. Electronic stability control is again the part of the powertrain. Active yaw control, parking system, tire pressure monitoring system, nothing to be called as PPMS, regenerative braking, hill hold control. There is called as BSRC, the protocol which is being used for V2X communication. So V2X is nothing but vehicle to vehicle communication, vehicle to infrastructure, vehicle to power station. In that case, there are too many things are X can replace with a different kind of infrastructure in that case. So this is DSRC is mainly used for V2X communication. Then voice and data communication, active cabin noise suppression, auto dimming mirror, interior lighting, event recorder. So all those features are controlled from some sort of controller. So it's kind of hardware, and on the top of the hardware, there is a software which is being controlled over here. And these ECUs we called as electronic control unit, called as ECU. These ECUs come together and talk to each other and share information between the ECUs. Nothing but there would be some communication protocol that is Canvas, which is worldwide accepted and again the standardized protocol in the automotive industry in that case. So this Canvas communication always broadcasts the message from one EC to other ECs. So in that case, these these are the communication being shared in vehicle network. So in vehicle network, nothing but we talk about the Canvas communication. So these features are associated with number of ECUs. So whatever you see on the screen, these are the functions or features in that case. This comes together to come up with the ECU, and that ECUs fitted in the vehicle itself with a different kind of architecture. So there are different kind of architectures used in vehicle itself. So if you know about threat modeling, so if you guys coming from the uh, cybersecurity, normal traditional cybersecurity, I would say in that case, not so like a banking sector from infosec, web application, mobile application in that case, or you're coming from the ICS word IoT, there is concept called as threat modeling. So as per automotive standards, cybersecurity standard, we call it as TARA. So in the TARA, in that case, uh, there's nothing but a threat modeling in that case. We try to find out the assets. And based on the assets we identify, we try to determine or deduce try to find out the threat associated with those assets. And we rank in that case. There are different kind of standards, or you can say categories. We can define the risk associated with that. That asset is nothing but your features as well in that case. So when we talk about vehicle or any particular issue in that case, so we try to find out for the asset, and based on the asset, we try to figure out the threats associated with asset itself. So this is a very good example over here. You can find a lot of asset associated with features in that case. And once the complexity of the vehicle get increased, definitely the assets get increased, and assets get increased, definitely the threats associated with the assets get increased in that case. So we'll see the next slide in that case. So why we bother? Yeah, we should bother because it's a cybersecurity. So uh, the people here, a lot of people are from the SCADA OT background actually. So well-known malware, right? Stuxnet, which who changed the entire world to how we can see it at the ICS cybersecurity, right? The same way the incident happened in 2015. It's not an incident; it's kind of research in that case. Two guys, Charlie and Miller, they found the way to control the entire Jeep. That was the Jeep Cherokee, that particular brand, the model of the brand actually in that case. They control the entire vehicle remotely. So there are different ways to do that, and there are different ways, methods in that case they did. uh, One of them, they reverse engineer the entire infotainment system, and then infotainment system have a telematics unit, and the telematics, or rather you can say the ISP they used for the telematics communication, it's nothing but there is no security at all in that case. So we can access publicly uh, IP addresses associated with the telematic unit, so they can scan and do anything. But the very interesting part, they modify the entire firmware itself and put malicious stuff in a such a way that they can trigger that particular message from the computer, and that particular message, I mean to say the canvas message, get executed on the vehicle itself, and they can control, they can kill the engine itself. So that first of first time they did with the Toyota car, I think surprise that was a hybrid car in 2013, and then say Toyota said it's a physical attack, anyone can do it, or rather there is no impact as such in that case. So you have to concentrate on that particular thing, which is very interesting over here. They said you need a physical access to perform those kind of attack. Yes, that is true at all. But after 2015, in the 2015, they demonstrated on the Cherokee, that is Jeep. What is the between the physical and the remote? Because if you want to reverse engineer the entire vehicle itself, you have to be physically over there. You have to reverse engineer the entire communication. That means you have to study the entire vehicle, attaching your debuggers, attaching your the can transducer kind of chipsets, and you have to search. You have to reverse engineer the entire communication itself, and then you have to dump some. You can say the firmware, and then again reverse engineer, try to find out those kind of vulnerabilities or exploits associated with the firmware itself. So in the Jeep itself, they do everything. They physically remove the entire infotainment system, reverse engineer, then they flash their customized the firmware in the infotainment itself, and then try to they use nano BTS. Nano BTS is kind of a device which can be used in the remote area where we cannot get the 2G, 3G, or 4G communication. To boost the entire network, they use nano BTS. So with the nano BTS, they connected the vehicle with the nano BTS, and they tried to do attack on particular infotainment system. Then they leverage entire thing, and then they found public IP addresses, and then they perform those kind of attack uh, uh, through the remotely in that case through their laptop. So if you people says or manufacturer or any tier one supplier says that it's a physical attack, no, it's you have to take care of. You have to consider those attacks as well. That physical attack can lead to remote things that would be possible. There is another event recently in the May 27, 22, 2024, that there are some cheap devices can be used to replay and relay attack on Tesla, and you can you can open the door and run out. The same way, Pound to Own 2024, they had a event over there, and there was a Tesla car over there, and these same guys, one of the company called Sinac, I believe so, or Active, I don't know exactly the name of the company. These researcher, they found the exploits on the infotainment system itself, and they try to jailbreak, and then jailbreak they control the entire vehicle itself. So they got 1.1 million dollar as a price, and you can say they got a car as well. So this kind of one to one competition, if you know the automotive security, you can go even with the telco. You can do even with the IoT devices, and they have programs in the ICS devices as well. There is another 2003 incident. Car owners warned that key fobs could be vulnerable to hackers. So there are some devices in the black market. They have a devices you can perform same relay attack. That means it's a key fob. Have wireless key fob is like you have LF and RF communication inside the with the key fob and the car itself. So LF is a low frequency level and RF radio frequency. In that case, it's a 125 kilohertz, 13.5 kilohertz in that case. Maybe in that, and in that, within the approximate area, or rather you can say proximity area in that case, if you come with a key, you can open the door, right? So in the relay, what they do, they increase the range of your entire the uh, network, or rather you can say wireless area, in such a way that you can open the door and you can start the engine with the help of those attacks. So these devices are in the market. They sell like 13,000 pound or $20,000, $25,000 in the market. You can take it and you can perform those kind of attacks. Nowadays, right now, it's happening in the Europe. Then the entire market, they steal the entire car, and then they open the car and then sell the parts and everything. Too many things are happening in the Europe region right away right now. So these are the things in the automotive industry is going on. OEM come up with a lot of you know techniques to avoid those kind of attacks, but eventually the researcher or any kind of the black-minded hacker, they come up with those ideas. They try to find out the exploits in such a way that they can steal those cars. And again, sometimes what happened, the researcher found critical vulnerability, but this vulnerability is not accepted by the OEM. But when they show the impact in the market, and what happened, the risk comes to the car owners and pedestrians, who the guys or the individual, the human being walks on the road, that risk onto those people, then that creates a bigger impact in on the OEM itself. And they recall, sometimes they have to recall the entire vehicles and that is the biggest uh, the business impact on the OEM itself. So recalling the vehicle is very dangerous, I would say, as per the risk or for the image in that case. Yeah, next slide.
Yeah, so maybe a quick bite here, Harun. Uh, we'll take question at the end, but yeah, I also had one thing to ask you. You mentioned that these attacks are very prominent now, and most of the times these devices, like the other ICS, they are not designed with security in mind. So one side is the old key fobs, which are working on radio frequency, and then you mentioned about the replay attack. Do you have statistics in mind that how many percentage of car have this replay attack issue?
So the I will talk about the India. I don't want to
Mm-hmm.
talk about other region as of now,
Mm-hmm.
but in India, I would say from the cars who released up to 2018, they are not vulnerable to replay attack. That's my understanding because they come up with a rolling key mechanism, but still there are different ways to do that to bypass
Mm-hmm.
those rolling key mechanisms and other stuff.
Mm-hmm.
But relay attack, it's on everything till now. I would say till now,
Okay.
it's
So
vulnerable.
basically, a car which is a fairly old car, let's say 5 to 10 years, and you have a flipper zero with you, you
Hmm.
emulate the RF, so
Yes,
you're basically able to unlock the car and then get access to it, right?
yes. But Flipper
Yeah.
Zero, you can do only replay attack, and that's
Yeah.
why
Yeah.
the vehicle which is affected with replay attack, yes, you can
Mm-hmm.
do that thing.
Okay.
But on the wireless key fob, key entry, wireless key entry in that case, uh, replay won't work in that case. But relay work. If you buy 25,000 or 20,000 device, you can do anytime. And you can in the night you can go outside and steal the car. But uh, as per the if you're a researcher, you can make those devices as well.
Yeah.
It
Yeah.
takes like I think so 1,000 $2,000 to make this thing, or maybe a less as well, $500 as well. But you have to have that competency to make those devices. You have to learn a lot of things, electronics and other stuff. And if you're a good coder, you can do those things. You
Yeah.
just
What?
need to
Yeah.
amplify the signals.
Yeah. One more question there as well. Like I mentioned about the infotainment system, and in the last few years, there is a big change in the infotainment for the car, specifically the Indian car sector. You see,
Mhm.
this all the Indian manufacturers they are focused on developing larger screens and
Yes,
advanced infotainment system. So did you try to test any of them, and
yes.
how what is your understanding of them being insecure as such?
Infotainment systems are insecure. It also depends on the features they implemented in the vehicle, the infotainment system itself. There is some attacks you can do with a FM receiver
Yeah.
on the
So
infotainment system itself.
so the
So you can,
infotainment is the biggest rat hole in the entire
yeah, yeah.
car
So
security. Yeah.
there is another guy. I also follow him, and he's very well-known guy from. They called as Canvas Guru, Tindel. His name is Tindel. There is nothing you can do with attack in the car. There is
Mhm.
always infotainment. He's very good. He's very good in the cybersecurity also. So he mentioned that the line actually, the quote, it always be infotainment system. So, so you can say that infotainment system is the biggest challenge in the
Yeah.
automotive
Yeah.
industry as well, because it's come up with a lot of features associated with the infotainment system. Even they come up with a browser facility, browsing facility. You know that then entire people who works on the browser fuzzing and everything. There are a lot of ways to do that.
Yeah,
Uh,
you suddenly will open the Pandora box of
yeah,
browser-based attacks.
absolutely,
Yeah.
absolutely. It's that infotainment's nothing but Android mobile phone or tablet, you can say, or iOS tablet in that case.
Yeah.
So there are some vendors in the infotainment industries who makes infotainment with a larger screen and a lot of facilities and the lot of sandboxes in the infotainment system itself to secure the entire infotainment. But there are some people who try to bypass the sandboxes in that case.
Wonderful. Yeah.
So we understood a lot of things from the internal and external communication. So what are the challenges nowadays? Here the challenges I want to address with respect to OEM, with respect to the individual who really want to come into this industry, and what are those challenges education wise. I really want to address those things as well in that case. So increasing connectivity is biggest challenge now for cybersecurity, or in that case automotive industry in that case. So V2X, as I said, the V2X is vehicle to vehicle, vehicle to infrastructure, vehicle to power station, vehicle to any kind of infrastructure. In that case, that complexity become larger, in connectivity become larger, and there is no aspect of cybersecurity. So even the charging stations are vulnerable to attack. So now I can connect with this charging station. How can impact on the power or electric utility in that case? So the charging station, when we connect the let's say charger from uh, the power station, electric vehicle power station, from to your electric car. So there is called as PLC. It's not programmable logical control. It's a power line communication. So power line communication connect with this charging station and the vehicle itself, and they exchange the information about the vehicle, and they start charging. There are a lot of calculation inside this power line communication, like with respect to voltage and current and everything. They exchange a lot of communication. So now these power stations also vulnerable. So what happened if you emulate the entire vehicle and you attached the entire charging station to that emulator, and you can inject a lot of communication, a lot of messages, right? You can furge those messages and attack on the power station. From the power station you can attack the electric utility. So this is kind of very different game altogether. So one system get compromised can be compromise other sector as well. So that's how the ICS, uh, in that case, electric utility comes together with the automotive industry. So that becomes very complicated in the future, because everything is going to be connected in that case. Now there is another one thing. I can give the example. This power station connected with payment gateways, right? So you have to uh, pay the money from your app, from your card, what is the facility they use. And again, that payment gateway connected with the banking sector or third party gateways, right? That can be compromised if the something credential or something stored in the power station itself. So the researcher or attacker or black hat hackers can take advantage of it. So there are many ways. So if you do those kind of threat analysis, threat modeling of power station, it can open lot of doors for of the threats in that case. So
Yeah.
this is again the V2X technologies. There is a third party integrations. So what happened post development, or rather once the vehicle comes into the market, there are different things are in the market itself. They come up with the third party products, products like fleet management systems. Fleet management systems are third party products which is not uh, you know uh, which is not compliance with the cybersecurity testing, or other automotive cybersecurity testing. So they have to compliance, and that is again the challenging, aspect in the automotive industry. Complex systems like ADAS. So in the ADAS, there are different kind of labels over here. So ADAS is nothing but Advanced Driver Assisting System. These ADAS have 5 level from 0 to 5. So from zero is there is a nothing automations, right? So called as zero, and 5 is totally autonomous. So in that case, you no need to drive the entire vehicle. So this is the entire complex system. So when we talk about the ADAS, a lot of sensors, like maybe it's a camera, lidar, radar, ultrasonics, or any other sensors they use, and that sensors sends the input to the ADAS ECU, and based on that sensing things, or the input comes from the sensor, it takes the decision and it send it to the VCU in that case. When we talk about VCU, VCU is nothing but vehicle control unit, who is the brain of the entire vehicle. In that case, who takes the decision. Uh, in another language, if I put it, and that VCU is nothing but a powertrain. The powertrain domain is responsible for chassis and everything, like braking and engine controls. These are comes in the powertrains. Nothing but it gives the power to run the vehicle. In that case, that's the powertrain actually. So this is becoming very complex nowadays, very complex. There are some architectures, like right now we using distributed architecture. In that case, EE architecture, electronics and electrical architecture, we say that. There is another called as they come up with a domain centralized EE architecture. Then now there are some uh, techniques or technology coming into the picture called as software defined vehicle. So these software-defined vehicles, it's a mixture of zonal architecture, zonal domain architecture, and uh, the IT infrastructure comes into the picture. So in the ADAS, you get the features. Let's say you have a car and you purchase last year, 2023, but in 2024 there is another car which is more advanced, but you cannot sell this car and then again you need to buy the car because that another car have a lot of features, right? So they come up with the idea called as software defined vehicle. In that case, same architecture, same ECU, only software get updated. The same like what we have with the laptop and everything, we get updated, right? So you don't need to change the entire laptop for Windows 12 or 13, right? So you need to update the entire software itself, operating system in that case. The same way, if you want to upgrade your features in the ADAS, you have to pay the money to the OEM and you need to upgrade. So this is software defined vehicle nowadays coming into the picture, and that's why the infotainment systems becoming large and becoming like giving a lot of facility in that case, and the infotainment system becoming software updater for other ECUs in the E architecture. That's the thing is going on. So the multiple powertrains in the coming into the picture because of that. So like there is called as ICE, that is works on the internal combustion systems. So the petrol and diesel now is coming with the BEV electric vehicle. So this complexity or multiple powertrains coming into the picture, like hybrid in that case, right? The combined two electrical and the ICE engine coming together, they call it as hybrid. So complexity becoming a big, huge, you can say the uh, Shiv, you there?
Yeah.
Yeah. So complexities becomes a huge challenge in the
Mm.
cybersecurity. Coming to the skill set. So now there is a big challenge in the OEM sector, tier one supplier, and a lot of company who produce hardware, who work on the softwares, right? So skill set is very important. As I said, the cybersecurity in the automotive is recently new in this field, And I know that the 6 7 years back ICS struggling with those things as well, ICS field or SCADA or OT, in that case. So you can find very few people in the industrial control systems cybersecurity, ICS cybersecurity. Now you can find plenty of these things, not much, but yeah, you can find it. It's the same with the automotive industry. You never find those skilled people. There is a challenge actually. So the automotive engineer who works in the automotive industry, but they don't know the cybersecurity. They don't know about the real and replay attack. They don't know what is the forging attack, how they modify the message or any kind of reverse engineering techniques. They even don't know what is the encryption and encoding. What is the difference? So a lot of things are there, because I gone through those kind of with the OEMs and not OEMs, like tier one supplier, and then they have a lot of problems. So as I said, the automotive industry is a dominating industry in the entire world. So they fairly understand the cybersecurity aspect. That is the very big gap over here. If the person come from the IT industry, IT, cybersecurity, mobile application, everything, but they have a very hard time to integrate themselves into automotive cybersecurity because they don't understand the jargons of the automotive industry. So it's a big thing. Even if the cybersecurity who are new in the cyber, who really want to come into the automotive cybersecurity, but they don't have knowledge of automotive background as well as the cybersecurity, then where they can go and find those kind of the knowledge, they don't have access to lab setups, right? So even it's with problem with the other industry as well, like in the ICS, how we can find the PLCs, everything level zero, sorry, level one and level two architecture you cannot find over there. So you can talk about the same thing with the IT and OT integration, but how about the Modbus, BNP3, and other Profibus communication? How we can attack on that? So because you have to have the lab in that case. The same story with automotive cybersecurity. They don't have car. If they have a car, but parents don't allow to touch, or any company, they really don't want to touch
Yeah.
to the to the cars actually. That's the story. And it happened with me as well. In the end, I purchased my car, you know, first electric car. First time I purchased my car, and that was electric, and that was for experiment only. Then I started my journey in the automotive industry, and I learned too many things in the electric vehicle, and I done a lot of research in that case. That is the big thing in the skill set point of view. Regulatory and standardization issues, yeah, lack of uniform standards. That is the big issue over here. So every country, if this OEM want to uh, produce a car and they want to launch in US or UK or in Europe or in Asia country or in Japan specifically, they have their own standards. So they need to follow that standards and they have to release their own vehicle in there, in that region. So that is the big issue. There is no uniform standards. So standards need to be implemented, such as ISO 2134. And these standards have to compliance. The company get compliance or OEM get compliance with ISO 21434 standards. There are some countries in the Asia as well, or other part of continental. They don't have standards, so they just build the vehicle and they run the vehicle in their countries without any cybersecurity standards. Hopefully, our India is getting mature now, and then we have standards. ARAI is doing great job in that case nowadays, and they are thinking, and then they are implementing those standards nowadays in our India. but still our Indian manufacturers have a problems, uh, and I hope they will address those things. Yes, so there is one interesting video. Shiv can play that thing, and I will talk about that particular video. You can
Sure.
find it on the YouTube as well. This is the thing. So we really talked about the four wheeler right nowadays, car and vehicle. What about the two wheelers nowadays? So if you calculate, there are millions of electric scooters in India. In the Asia, you cannot. There are a lot of two wheelers in the Asia as well. So, and now they are using electrical in India as well. We are using electrical. So electrical cars are also another big concern.
To start kar.
So we performed some remote attack on the electric scooter. So we successfully killed the engine. So that's the thing. So the OEM from two wheeler who is taking care of these things, they should aware of these kind of attack. What happened? I'm running my scooter at the rate of 60 or 70 kilometers per hour on the highway itself, and suddenly my engine get killed. Though it's speed, but there are a lot of chances can that risk goes to the scooter owner, right? So there are too many things are there over here. There is
Yeah.
another video from the four wheeler that is interesting. I can explain those things very well because it's a, you can see it's a MG Hector over here. So in that case, we checking the connectivity that everything is connected over here. So from the mobile phone, I try to control that the telematics unit. So telematic unit in the car itself with the infotainment system. So it comes infotainment system. Then behind that, there is a telematics unit. So we are just checking everything is connected. Okay. So now we are parking over there, and we have set up for those attack. So setup we have we made 4G connectivity. So nothing but we created eNode. eNode nothing but we call it as a tower in the telecom, or rather you can say in 2G we can say BTS. So we have GPS location. So our device is the car is located at that particular thing. So now we have set up over here some antennas, and we have laptop. We running our eNode V over here, fake eNode V. Okay. So now car is parked, and this parked. The car is attached to our thing actually, and we send such a mal-crafted packets in a such a way that entire telematic device was down. It's dead. So it cannot connect to any real tower or fake tower. It's a problem with the modem itself, and because of that, you cannot relocate, connect your uh, relo- uh, get the coordinates of the vehicle, and even you cannot send any message remotely over there because this has happened on the telematic device modem itself. So that particular modem can impact on the brand of the OEM or image of the OEM. That can also gives impact on individual as well. If something happen or someone steal the car, you cannot locate your car itself. So it's it's the risk is on the OEM as well as the individual in that case. It's the biggest thing actually. So it's a big problem in the telematic devices.
Yeah,
Yeah.
not worried about the The vehicle theft. I'm worried about the safety concern here, Arun, and that is quite a good demo that you have done over there. This gives a perspective that what can go wrong. You basically kill the vehicle, and with the scooter turning the powertrain off while it is running, it is completely disastrous.
Yeah,
You know,
absolutely.
yeah,
I can extend this attack to control vehicle,
yeah, yeah.
but I don't want to open my car.
Mm. Yeah, that's the biggest challenge also, and some of the challenge that you have mentioned are quite significant. When something new comes, new technology comes, a lot of small companies, startups, they'll start to work on it, and then the focus is on product development rather than the security aspect, and that is
Absolutely.
also happening in this area as well. That they are working more on functionality, not on security aspect. Then we access to the device itself is a challenge. I also spoke to one more friend around 4 years ago,
Hmm.
and he was getting started with understanding of a CAN bus protocol,
Hmm.
and he did not have access to the ECUs, right? So then he went to a scrap dealer and then found an old Centro car and then get access to the ECU, and then he understood the CAN bus communication. So those are the challenges. Also, the complexity of the vehicle ecosystem itself is very high, and number of
Yes,
vendors,
yes,
and number
absolutely.
of activity, and number of protocols. That also brings challenge to this one. There are some effort that are going on, and ISO 21434 is the protocol that is trying to put some uniformity around it, and maybe in moving forward, the governments will also take some good step to standardize these equipments. Like 62443 is now being discussed a lot in the power sector and other manufacturing industry. The same way we might see
Yes,
ISO also being discussed.
yes, yes.
So the question is, how do we start now in the journey?
Yes, definitely. So again, I will address with respect to OEM and the individuals in that case who really want to deep dive in the automotive cybersecurity. Before I say, before we talk about this one, I would like to address one thing as well. For two-wheeler industries, there is one there is one standard called as UNECE R155. R155. They introduce the regulation for motorcycle, two-wheeler motorcycle, which can exceed
Mhm.
more than 25 kilometers per hour. They have to address or compliance with the R155. So I think so in June, or they already started, I believe so. They definitely roll out the entire R155 for motorcycle. So if someone from the OEM, from two-wheeler industry, they have to take care of. They are listening to you, definitely they have to take care of this R155 regulation seriously for two-wheelers. Two-wheelers are more vulnerable than cars, very much vulnerable.
Yeah.
So, and the cost for, you know, I don't want to talk about that.
Yeah,
They have,
basically the incentive and the blocker for getting into hacking is smaller compared to the four wheelers, because most of the two wheelers have very less electronics and they are using the Android systems over there, and also because of our Chinese scooters, which are from different vendors, they are directly imported
absolutely,
without any
absolutely.
testing. So that also is a big perspective here. Yeah.
Soon we are going to release one Chinese vendor things. We
Mhm.
successfully did a lot of testing on that, and we retrieved the firmware, and then too many things we did in that case actually. So definitely we'll talk about that in the future as well. So
Definitely.
so
Sure.
because you mentioned about the Chinese stuff, that's why I'm talking
Yeah,
about
yeah, yeah, yeah. Yeah, so this is a well-known fact that we have those low quality, low standard scooters running in the market already. So
Yes,
definitely,
absolutely.
they would not have that maturity, that kind of security being even thought of. The build quality of the scooter is such that if somebody bangs it, then the entire body goes for toss. So what can you expect on the electronics over there?
Yeah, yeah,
Yeah,
definitely.
yeah.
So yes. So how to start? That is a big question now. So for automotive, as per my understanding and the experience, when I started working with some projects on the automotive cybersecurity, tier one supplier OEM, they don't understand the scope. What exactly the scope of the work? So the scope, is it on the vehicle level or component level? When I say component level, that means it's a ECU level. So the component, which is microcontroller inside the vehicle, which have a lot of features and which communicate over the canvas or FlexRay or most protocol. So yes, so in that case, they don't understand the what is exactly the scope. So they first understand the scope, what is involved, whether it is vehicle level or component level. If it is vehicle or component level, they have to border something like black box and white box. So black box, which is the vehicle they give you, and they don't provide any information about that. And then you start working on that particular thing, like black-minded people, black-minded hackers in that case, and you have to reverse engineer. Then a lot of phases are there. You need to do that. And the white box, they will give you every information about the car itself, component, how many ECUs are there, what kind of ECUs are there, and they will give you the specification document. The specification document is nothing but Bible for automotive engineer. So everything related to canvas, like arbitration ID and the message is mentioned over there. And they also mention the event. If they trigger that kind of arbitration ID with the message, what kind of features it will trigger or event trigger. That kind of information inside the specification document, and that spec books have detail of hardware and everything, whether they use hardware security module in that case, or a TEE model they used in the hardware itself for a protection mechanism. Everything mentioned the white box testing. So you don't need to do reverse engineering. You don't need to put a lot of efforts, or don't need to put efforts on the reverse engineering itself. The same way with the component level, if they give the ECU, they have to do black box and white box, same aspect what we do in the vehicle. The only the way they perform the attack, it's a different level. So they have to mention whether these, they have to focus on the hardware or not. So hardware security is the very important aspect in that case. So I would say in that case, as per the OEM, they have to understand the scope first. They have to plot the scope first, determine, understand. For that purpose, they have to implement cybersecurity management system, the department in the OEM itself, and who will have a skilled employees in that case. So in the skilled employees or consultant, they need to hire, and they should have the skill set. So in that case, as I said, automotive engineers, they should aware about the all type of attacks in the industries. But awareness is a problem, big challenge. Cybersecurity standards they need to understand, like ISO 21434 and the R155 and J3061, and they should have a mindset in that case. So they have to go through the cybersecurity standards for like penetration testing standards. They are, at least they should understand the jargons in that case. Cybersecurity, which is non-automotive cybersecurity, so in that case they should understand automotive domain. So they should understand what are the domains in the vehicle itself, like what are the ECUs and function of the ECUs, and what kind of domains and architecture place in the vehicle itself. So they should know every jargon which is used in the automotive domain. And they have to have the lab, which is very big challenge. Some labs are simulators they can use, like IC sim is one of the good simulator, like instrument cluster simulator. You can practice them, and that simulated all the information or canvas communication in the simulator itself, and they can do reverse engineering and perform some sort of attacks. Or You can buy instrument cluster, as you said. Your friend went to the scrap and they took the EC out of it and infotainment cluster, and they understand wiring and everything. The best part, you go, those people take the entire vehicle as a scrap and understand wiring, harness in everything, and power on the entire device, and you can start working on that. That's, you have to spend little bit money in that case, and how you deal with a scrap guy, that is more important.
Money and time, both the things. Yeah.
Both the things actually.
And your negotiation power.
Yes.
Yeah.
And another part is it's always applicable to automotive engineer and non automotive cybersecurity guys. They have to do trainings is very important for that. Trainings for standards, trainings for cybersecurity, as Amina Sek also do a lot of trainings program for different OEMs and a lot of cybersecurity and automotive engineers. Soon we are going to launch LMS system in that case. So entire world, anyone from the any part of continental, they can learn remotely. In that case, the entire automotive cybersecurity. So training programs need to be in the place. Very important in that case. So
Yeah.
they should go through the entire training and they have to practice on the lab itself or simulator, and that's how they understand. And all automotive engineers uh, who responsible for developing softwares and hardwares and everything, and who works mainly in the system department, they should understand these trainings, because if you do understand at the time of making vehicle or in the life cycle itself, we can concentrate on those aspects. So from the scratch, you can see the most of the risk is mitigated at the time of development of the vehicle or designing of vehicle. That is very important aspect. That's how you need to you can start. Standards such as 21434, UNC, ECE, R155, J3061, you have to go through those standards as well, which gives the positive impact on the entire team and the entire OEM infrastructure, or you can say in uh, the vehicle life cycle in that case. So so you should go. You have to do that actually. So coming to the global standards, so ISO 21434 is the standards which is globally accepted standards, which addresses growing need for cybersecurity measures in automotive industry due to increasing connectivity and complexity of modern vehicles. So whatever you see modern smart or smartest car on the earth, they have to go through the 21434, which has different kind of domain inside the standard itself, and you have to go through the entire standards, or you have to implement in that case. Even ECE R155 is a framework to ensure cybersecurity of vehicle, thereby protecting them from cyber threats throughout the life cycle. So when you're plotting or going for the developing the vehicle, so you have to come up with R155 standards. You have to go with a framework, and framework is nothing but to implement cybersecurity management system in the for to protect the vehicle itself. So that management need to create in that case. And very important, J3061. Lot of OEMs ignore these standards, but they don't know the 3061 is a de facto standard for ISO 21434. That ISO 21434 is originated from 3061. It's very important, and it's very important for automotive engineers and developers to implement effective cybersecurity measures throughout the entire life cycle of vehicle. So I saw a lot of people ignore this kind of J3061. Some of the things are not mentioned in 21434, but you can find those solutions, find those things in 3061, J3061. As per my understanding, and as per my uh, you know study and research, I found that actually when the people that ISO 21434 is not introduced uh, in the world officially. I used to use 3061 J3061, and fortunately these are the same standard. So ISO 21434 is derived from J3061. So if you learn those standards, definitely it will improve the cybersecurity management in that case.
Yeah, so now we are at the last slide of our discussion. Yeah, we have this discussion is quite comprehensive, and there may be some certain areas that we can focus, and this can be divided in terms of the good practice for the automotive manufacturers or the OEMs, and there could be certain things which could also be applicable to the professional who want to get into it. So yeah, we will maybe just keep this slide on, and then to not to stretch the time, maybe I quickly will take some of the question. This is self-explanatory. People can read it out, but maybe I have certain questions which might give answers to the question that people are also asking. So, what do you think, Arun, is the requirement for the professional who want to get into the automotive security? What kind of a skill he need to have? Do they really need some background in automotive industry, or they can come from any industry as such?
Yes. So I would say for cybersecurity, I'm not talking about automotive cybersecurity. In the cybersecurity, anyone can come into the picture. And
Yeah.
end of the day, you have to research, you have to understand those jargons, and you have to take trainings and everything.
Hmm.
But if you talk about the automotive cybersecurity, so if you have the automotive background, that would be the best. Okay,
Yeah.
but you have only cybersecurity knowledge, that also will be the best. But it's like vice and versa. So if you are in the cybersecurity, then you have to understand and go through the entire, I would say, overview, like little bit the surface of the onion. You have to learn about the automotive industry, some ECUs and everything, how they work. If someone is providing training, you can attend those things, and you can go deep dive into the. If you know only CAN bus and you can send the message, craft the message and sending on the network, and you say you are hacker, no. So you're not hacker, you're not control vehicle. There is no risk at all. So
Yeah.
you just sending the message, nothing else. So if you're treating yourself, you're doing this thing, no. So you have to go in out of the box. Once you understand, once you take the training properly or research properly, then you will figure out. So yes, there is no background needed at all, as per my understanding. You should have only courage to learn and curiosity. That is most
Yeah.
important in that
Yeah,
case.
yeah. You need to be curious, right? Absolutely valid point. And cybersecurity is like that. You need to always be curious, question your findings, and then you will learn more.
And if,
So yeah, yeah,
again,
please.
like in the ICS, like people like you, Shiv, actually can be a mentor for those people. And in the automotive, a lot of people are, you can take a mentorship from them,
Yeah.
advice from them. They can guide you what you have to do, what you not to do in that case. That can grow your knowledge very fast with trainings, with research, articles, and everything. You'll go ahead. That is
Yeah, maybe one more additional question to this, Arun. Like, one is getting the skill, but like ISO or IEC 62443, there is a professional certification also attached to it. You can be a 62443 cybersecurity expert. Similar to this, do you think in automotive industry also is a certificate available like 21434? Do they also certify professionals, or it's only for
Yes,
the?
yes, they
Uh,
have for same way. The ISO 62434 4443 is for manufacturing and the individual
mhm,
as well. Same
mhm.
way ISO 21434 is for both way actually in that case. And there are some
So,
bodies like TUV, Renland in that case. They provide a lot of trainings on the ISO. automotive ICS and automotive background. There are some affiliated with some institutions are affiliated with the TUE, like us, like Aminasec and Uno Academy is affiliated with. There are many companies around the world. They are affiliated. They have their own certifications. You can do those kind of certifications as well. So
Yeah.
individual can be certified. Yes, there are certifying body like TUE and other Cyprus. I think so. These are the people, or these are the companies who certified those people.
Yeah. So right in time, we had a question also on this. Harishankar was asking the same thing. So yeah, we have already answered it. There are different techniques to get into this. Like you can be a, white box security consultant or maybe a black box security consultant. So what is the methodology an individual can take to start a journey into automotive security according to your?
Black box or white box. Uh, okay, when we talk about the black box testing, so you have to think out of the box. Anyways, if you're white box or black box, doesn't
Mhm.
matter. So if
Yeah.
you're thinking out of the box and if you well knowledgeable about that particular topic, definitely yes, you can find a lot of vulnerabilities in that case. Or maybe you introduce a big attack vector to world to how we can find the bugs inside that actually. So that the way you can do actually. So in that journey, again, you have to go through a lot of thesis paper. A lot of PhD peoples release a lot of thesis regarding the automotive penetration testing, or rather, they come up with the anomaly detection system, how we can mitigate. So incident response is another challenge for automotive industry. So what about if you find a lot of threats, everything, like how we can respond to that particular threats or incident in that case. So in the banking sector and in the networks, they have SIM. Even in the ICS, they have SIM as well, right? So same way they have vehicle SOC. The vehicle SOC is going to be prominent in that case. Once the all uh, 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 vehicle software defined vehicle implemented, this vehicle stock become very huge in this industry. Now, a lot of OEMs are using vehicle stock as of now, but still, some of the very critical attacks they cannot find, such as wireless key attack. No one can find. There is
Yeah.
no the method to find, but there are some ways to do that. But still, industry is behind actually in that case. There are some Fyros attack or injection attack on the canvas. No one can understand that. No one can detect that. So there is a biggest challenge in the automotive industry. But they can find some sort of the incidents which are recently Autosar security. They produce anomaly detection methods. These library you can embed in the ECU and you can say that yeah we have anomaly detection system, but no way, you
Yeah.
cannot mitigate, you cannot detect some of the attacks in the uh, through the vehicle SOC. So these, the, I have talked about the vehicle anomaly detection system on Canvas and Link protocol in 2019. We are the first people who introduced that anomaly detection system in front of world, and we successfully detect those things. How the all type of attacks in the on the system. No, I mean to say in the canvas and the lin protocol. We also attach
Mhm.
that particular product to the vehicle itself, and we detect everything. So the thing is, these attacks still, the the companies who claim that they have vehicle SOC, but I gone through the entire documentation or some of things I attended, they cannot detect those things. There are some
Yeah.
challenges. Yeah.
Absolutely. So basically, there is a resource gap, and then the research paper could be a good start because we
Yes.
don't have access to real system. Yeah, that's a really good input. But I also had one question here. Like you mentioned about Canvas, Lean protocol, and somebody when you're presenting, I've also asked this: that all these different entities that you mentioned, are they communicating only with Canvas, or are there different protocols as well?
So prominently in the world, Canvas are there. Canvas FD, Canvas, you know, uh, Canvas is introduced in 1987 by Bosch actually, and
Mhm.
then they rectified and they come up with the FD as well. Recent, not recent, it's that time also.
Mhm.
So Can FD they are using because they have uh, bigger payload to encrypt some messages. So these Canvas is worldwide accepted. I believe so. 70 to 80% vehicle works on Canvas and Canvas Ethernet, DOIP in that case. So
Mhm.
these are things are they use. FlexRay are very costly. Some of OEMs, big OEMs, they use FlexRay as well. Lin protocol is mostly in the body control module they use for
Mhm.
SL D or C something. These kind of functions they Lin protocol they use. But prominently, I would say everywhere you can see the canvas.
Yeah. So Canvas is the biggest one amongst all the
Yeah.
communication protocols for
Yes.
automotive. Yeah, and then Sainath has asked this question that do we need, when you mentioned that you need to have physical access to the vehicle to basically get the understanding of security. So do you need the access to the vehicle, or you need access to the key car? So though it is addressed to me, maybe I'll add my 1 cent. Of course, the key will only give you what kind of communication you want to send to the vehicle. And to understand the overall architecture and the network infrastructure of the vehicle, you need access to the vehicle. What would you like to add here?
So you need everything
Yeah.
in that
Yeah.
case. If you're only for external communication, if you're doing some research, in that case, the car and the key fob. That's it. So external communication, it like maybe your 2G, 3G, 4G communication, your key fob communication, your FM and everything. So you can do ton of things, even the radar and the lidar and the ultrasonic, sensors in that case. So you need a car and that's it. But you really want to do canvas attack inside the vehicle itself, then you have to do something kind of you need to have physical access to the vehicle itself along with the key. Without key, you cannot open the car, right? So you need a key and open the car and then attach the debugger or can transducer, and then you can play with it, understand it, reverse engineer a lot of communication in that case. You need to bypass gateway and lot of things. There is not such a thing that you plug it and do magic. No, now come up with a lot of security aspect nowadays.
Yeah. So then there is a maybe a comment, not a question as such, that Range Rovers have the problem of key fob relay attack, and they have very bad reputation in the market. They have signals always on transmitted, and then insurance company won't insure them. Do you also have some understanding of this particular brand? I don't have any knowledge about these specific
No,
brand
no,
being.
that comment is very right actually,
Mhm.
because why the fleet management comes into the picture because of insurance company. So when you have a accident, how we can say that uh, that this has happened because of the car owner's problem or something else. So you cannot justify these things. So that's
Yeah,
why
yeah,
they come up with a fleet management system. It will understand the style of your car by recording all canvas messages, and the analytics shows that you drunk over there, you have a problem, you're not a good driver or something, and then they can bypass the insurance, right?
yeah,
So the same way they have to come out of this kind of things, like when it comes to key fob. So key fob signal it always be on. Why not? That's the
yeah.
feature actually. So you
Yes.
cannot say anything. That's why a big battery we have now. We have EV as well. So key fob, the only thing is it's like in the amateur way, Amateur way, you can have a RF signal blocker, like they have pouch and nickels. It will block nothing but Faraday cage, you can say. In the Faraday cage, you can make kind of material which block the signals uh, going outside from the key itself. You can do that too. But you have to be precise in that case when you want to open the key from your pocket or that particular RF blocker pocket in that case. So
Yeah.
that's the one thing.
Yeah, so the next question is from Sanket. He is asking that he's having 15 years of experience as a control engineer, and he wants to get
Mhm.
into automotive security, and he wants to know how would the industry will react to it. Would they consider somebody starting afresh after 15 years of automotive experience, or they will only consider 5 6 years of experience guy?
So
So
yeah, yeah.
yeah, yes, Arun, please.
Yeah. So in that case, as a control engineer, I don't know what kind of control engineer into. I mean to say, I understand that he's talking. He's from the OT background or
Yes.
ICS
Yeah.
background in that
Yeah.
case. So if you're controlled engineer, you know the Modbus communication. You already worked on Modbus communication, DNP3 and
Mhm.
Profibus, and a lot of EIP and IP communication protocol in the industry itself. I would say there is no problem at all,
Yeah.
not at all, because you know the system, you know the hardware, you know the everything. So you're the best candidate to understand those complex systems, and you know the cybersecurity. You know, understand. It's the same way. Modbus communication, broadcast communication, right? In
Yeah.
the itself, master and slave based. Same way, Canvas broadcast everything. So half
Yes.
of the things are already over here. So I
Yeah.
mean to say, see, CAN bus is clear text protocol. Even the Modbus is clear text protocol. On the top of that, they're coming with encryption standards, right? Same way and same problem. If you have the encryption on the Modbus communication in the electric utility, and it delays for seconds, the communication, it will be the huge loss in the
Yeah.
$1 million, right? The
Yeah.
same way in the car itself, if we apply too much encryption or come up with a proprietary encryption without checking any standards or something like that, then you press the brake and something after 5 seconds you apply the brake, right? It
Yeah.
automatically apply the
Yeah.
brake. Then it risk comes to individual. So I'm just giving the example that you are from critical infrastructure, specifically Sanket from critical infrastructure. Automotive comes in critical infrastructure as well, though
Yeah.
being used by the individuals, but it's ultimately comes on the individual
Yeah.
life.
Yeah. So my 1 cent here, like how I see such questions, I get to see such questions a lot. One thing that you need to understand that the 15 year of experience is something that you earned after investing 15 years, and the skill that you are targeting is a skill that you can learn quickly. So correlate your experience with the skill and then go for the role that you are targeting for. And definitely will have good returns uh, with your kind of experience. Maybe the last question of the day. I am not able to see some of the question directly in Restream. So maybe after this, I'll quickly go and then check. But yeah, the question is, do uh, we have some virtual environment to start our journey? Are there some simulators available? Are there some good documentation available? Uh, how, how would you like to answer this? I don't, you already mentioned that you are trying to build a LMS, and that would be a good start. But apart from that one, are there some existing resources available?
Yeah, so there are some existing resources available, but they are the same thing. You can search on everywhere. They're the same, but there are some research going on. You can, as I said, like you need to go with a research thesis. You have to understand those things first, and for virtual thing, you can, I just mentioned IC sim is one of the thing. You can search how I can hack canvas, so you will get a lot of information about the simulator which I mentioned, IC sim. So you can install it on your Linux machine and you can do same thing in that case. And again, From our end, we are do in premise training from the Minasec for those kind of automotive industry, so automotive penetration testing skill. So where you will find practical thing. So in our training, we do it on the real thing, on the car and the e-scooter, not on the simulator. So simulator we do, you can do it on that, but we have components like ECUs and instrument cluster, and we have e-scooter and the car as well. Two, three cars we have. For always we do research, and same we do training on those cars as well. It's just like a live thing, live hands-on experience in that case. So that's how it is.
Yeah, that's wonderful. Yeah, most of the questions are towards that direction only, and I think you have answered it very well. Before we close, let's take a last question. There is one question from Madhuri that are there any specific educational major or skill required to start with automotive security roles in a company? My answer to it is like there is no specific requirement, and Arun, you have also tried to give this answer that anyone who is having interest in security can actually come to security, but you need to demonstrate that interest, your learning, and the skill that you possess. There is no
Absolutely,
specific requirement of the background as such, in, at least in the security field, and you'll find most of the big black hat hackers they don't have any formal education being finished. They will always
absolutely
be
correct.
more skilled than being a formal graduation or something like that. Maybe a last 2 cent from you, Arun, before we close for the day.
Sorry, come again.
Maybe last few sentences from your side about
Yes,
automotive
yes,
security will
definitely.
be interesting.
Okay, nothing is secure.
Yeah,
Nothing is secure because we are
yeah,
talking about cybersecurity. Absolutely, I'm telling you,
mhm,
if I'm not able to do that, someone come and do that, right? So it's
yeah,
always be research, and the black minded people, the black hat hackers always behind us, and
mhm,
they try to crack those security, I would say, in that case. So whether it is airport, whether it is ICS, whether it is aviation planes or satellites, or anything in the automotive industry, or IoT or telecom, nothing is secure. So don't think that you're secure. Something is implemented in the system itself, and you think it's no one can hack. No, that's the myth.
yeah, yeah.
That's the myth. So
Absolutely, yeah. Security is not a one-time job; it's an continuous process, and it will evolve more and more. More people will jump to the bandwagon, then they will discover more issues, more vulnerabilities, and then ultimately will learn more. Very well said, Arun. And I can assure you that I enjoyed the discussion a lot. And when we were preparing for it, you have already mentioned that I'm not sure whether 1 hour will be sufficient. And I can see the excitement in you, the knowledge that you bring in this topic, the research that you have done over the years is visible in your talk, in your discussion, and the patience through which you try to explain it is completely amazing. So this is
thank
one
you.
of the best discussion that I had on the security topic. I would like to take it forward. Maybe next time we'll do a little bit more technical discussion, and I
Anytime.
can also see the same kind of response coming online. Most of the people stayed throughout the discussion. That itself shows that how much uh, patiently they were listening to the talk that you are giving. So thank you for this knowledge bringing to this platform,
Thank you
and
so
I look
much.
forward to discuss more on this topic. Thanks, Arun.
Thank you so much. Thank you so much, everyone. Actually,
Okay, then thanks everyone. Thanks for joining us. Have a very good evening, and we'll see you next week with a different topic. And if you like our work, do tag us on LinkedIn. We will look forward to your comments and your suggestions for new topics to be discussed over the Huddle platform. Thank you.
thank you. Thank you, everyone.